Hello and welcome to the Unit 4 podcast on section 11.2, Mass and the Mole. I'm Mr. Sakaguchi,
Which makes me Mr. Lin.
and here we go. So the mass of a mole. So if you go back to our dozen idea, if I have a dozen
Eggs.
and a dozen cars, in terms of amounts, they're the same, but they don't weigh the same. So similarly, if we have the same number of atoms of different elements, they may have the same number of atoms, but they don't weigh the same. So the other nice thing about the mole is that allows us to kind of relate mass to the number of particles as well.
Right, because, when we deal with chemical reactions and such, we're dealing with not the weight of the elements, but the actual individual particles. So we definitely have to know how to convert from the mass of an element to the actual numbers that there are.
So there's something known as molar mass that we're going to have to relate. So we're strictly right now going to talk about molar mass with respect to atoms only. For atoms, the molar mass is equal to the atomic mass in AMUs. So the numbers you see in decimals on the periodic table is basically how many AMUs an atom weighs, but it's also how many grams a mole's worth of those atoms weigh.
Right, because the two are actually related to each other. As a result, you will wind up with some decimals, just like 1 mole of chlorine is going to be 35.5 grams. And this takes into account like the isotopes that we talked about previously, so that no matter what you're weighing, you're pretty much spot on with what you got.
In general, guys, try and round your molar masses for atoms to the nearest tenth.
Right.
Don't round it to the nearest whole number. In some cases, you'll be able to, but
Most
keep
of
it to
them.
the tenth.
Right.
So using molar mass. So what we're going to do is we're going to add to our mole road. So the bottom part of this figure on the right represents the addition to the mole road. You remember the top part from our previous podcast. But the solution method is essentially going to be the same. We're going to start with our given number. We're going to find where we are on the road in terms of the units of the given. And then we'll work our way to the destination and figure out what we need to multiply by. And again, we'll double check what we multiply by through unit cancellation. So let's say we were going to calculate, let's say we were given grams and we're going to calculate moles. So let's say we were asked to convert 85.0 grams of silver into moles. So where are we on the mole road? Well, the grams tells us we're in mass. Remember,
Right.
mass and grams are the same thing. And we want moles, so I'm going just up to the middle part of the street. And when I do that, this is what I multiply by, what you see in bold.
So as is shown in the ratio, the molar mass is in the denominator, okay? And you know this, again, because from the previous experience, you're going to want the same unit in the denominator. And then we're going to reference the periodic table, which tells us that the AMU, or molar mass, is going to be 107.9 grams per 1 mole of silver, okay? So we're going to start off by writing out our unit, or our given amount, 85 grams of silver, over 1. And then we're going to multiply it by the ratio as given in the as given by the periodic table and in the form of what's written on the mole road. Again, because we have grams of silver here, grams and grams are going to be able to cancel out. Like so. So as a result of the dividing, we have 85 divided by 107.9, and then we keep the moles, and then you wind up with your 0.788 moles of silver.
Right, one thing to point out here is notice how for the mole or represented street, if you will, of the figure, notice how there's specific numbers given for both the numerator and the denominator. In the mass mole part of our road, notice how I don't give you a specific number, it's molar mass. Basically, molar mass is going to have to be something that's you're going to have to calculate or get from by referencing the periodic table.
Right.
So the molar mass will be different every time depending upon how the problem is written.
Right, it's not a constant.
So let's say we're going to go in the reverse direction. So let's say I gave you 13.2 moles of lead and I wanted you to find the mass in grams. So we're in the middle part of the street and we're going to go down. So we'd multiply by the molar mass over 1 mole. So we'd go to the periodic table and we'd round the molar mass of lead to about 207.2 grams. and then we start with our given over 1, which is 13.2 moles. We multiply times molar mass over 1 mole. Notice how moles cancels,
Follow through on the multiplying.
and we end up getting 2735 grams of lead.
And that's it. Easy.